on a paper. So that is basically drawing, right? So the art of representation of an object by systematic lines or illustrations, the way you express your thoughts, that can be termed as drawing. Now, drawing can be classified into two important subdivisions. One is your artistic drawing. I hope you are familiar with the artistic drawings. Many of you maybe are artists here. You have gone through classes and you have given exams, and maybe most of you are very good at artistic drawing. And the next classification is engineering drawing. So I'll be training you mostly on this portion, which is your engineering drawing. I'll be training you on that, and you may be expert in artistic drawing from beforehand. So here in this class, you are going to learn about engineering drawing. Now let us see what we mean by that. Now, what is actually artistic drawing? It is basically the painting or the drawing that you do, and artistic drawing, it is drawn from imagination to reveal some aesthetic sense. Okay, so the art of representation of an object by the artist from his imagination or by keeping the object before him, right? So he can imagine something, or he or she can see something, some object before him, he can draw that, right? So that is basically a painting or a poster, and you can see such drawing in advertisement boards, etc. That is your artistic drawing. So these are some examples of your artistic drawing, and many of you are very well familiar with artistic drawing. Coming to engineering drawing. Now, engineering drawing, it is the art of representation of engineering object, right? So since you have entered into a degree course, for each and every say machine or object, you have methods of showing that in terms of engineering language. So the language of engineers is engineering drawing. To convey any engineering information, we have engineering drawing. That can be anything, drawing of buildings, road, machines, some circuit diagram, etc., etc. Right? So the art of representation of engineering objects is done with the help of engineering drawing. So you can have buildings, you can have roads, or you can have machines. So engineering drawing, it is a technique of creating graphical representation which contains necessary information such as dimension, some specification, some notes, using which an abstract concept can be transformed into real world object, right? So whenever you are, say you want to manufacture something, when you want to manufacture something, you have to convey the information on a 2D sheet, on a two-dimensional sheet. You have some 3D object, 3D object which you wish to manufacture. You have some 3D object which you wish to manufacture, and you have to represent that object on a 2D sheet with the help of engineering drawing guidelines. So basically, engineering drawing, it is universal language of engineers, right? It is the same and one language of engineers. And this engineering drawing, if you wish to manufacture something, it should contain all the necessary information such as the dimension, the specifications, if you wish to provide some note, using which the abstract idea that you have in your mind can be transformed into a real world object, or you can convert it easily into an object. Any questions up to this?
No, sir.
Great.
No, sir.
So engineering drawing, it is the language of engineers, and it is a means to communicate his or her idea through designs to others, and it is a universal language, right? Say if I draw something here, someone in USA, he should also be able to decipher from the drawing what you are trying to convey, right? So a drawing by an engineer having engineering knowledge for engineering purpose is engineering drawing, and it is the starting point of all engineering branches, right? So each and every engineering branch should have knowledge about engineering drawing. So to whatever branch you may belong, you should be having perfect knowledge and knowledge about the engineering drawing as well as scale of the drawing. As the bad language is unpleasant to read and communicate, so also a wrong drawing will worry a trained eye, and you will not be able to get the desired product. You won't get the desired product. So even a small error committed by an engineer in his or her drawing may misguide the workman or operator, and ultimately the construction will be a flaw. Okay. So this is a example of engineering drawing, how it looks like. So you have some information at this corner, you have some information at this corner, right? So likewise, here you have the drawing with all the dimensions, all the necessary dimensions, and in engineering drawing, at a later stage, you are going to see that to reveal a certain information, we use different kinds of lines, we use different kinds of pencils and set of instruments. So this is an example of engineering drawing. Okay, so now the building that you have, this is a 3D model. Okay, this is a 3D model, but whenever you see any plan of any house or something, you will notice, if you go through the plan of your house that you are living in, you will see that it is a 2D representation of your house. It is a 2D representation of your house, and the engineer or the person building your house, he will easily be able to read the drawing, and subsequently he is going to build your house, right? You go to any civil engineer or you go to any mason or somewhere, right? The drawing will be universal and all of them will be able to build your house. This is another example of this is the example of the, say, Eiffel Tower, right? So see how all the necessary informations are provided by the means of engineering drawing. One more example is the aircraft that you have. See, so many small components are present here. So you need to specify each and every component that is used to build the aircraft, or rather to manufacture it. Each and every nut bolt. What is the size of the nut? What is the size of the bolt? That also you have to specify on pen and paper. Right? So this was your helicopter that you saw. See, so many numerous number of parts you have here. Sorry. See here. So more than 100 parts are there in this aircraft for building this aircraft. See here, each and every part has been mentioned here, along with proper information and proper guidelines. Coming to the drawing instruments that you require. So drawing instruments are used to prepare drawings easily and accurately. So your drawing should be accurate and it should be drawn to proper scale. Okay, so your drawing should be accurate and it should be drawn to proper scale. For that, you need some instruments. For that, you need some instruments. Let us see what are the instruments that we require, and I'll instruct you on what instruments you should be having so that you can successfully complete this course. So the first thing that you need is a drawing board, right? So since you are not here in the campus, I cannot show you the board right now, but I'll try to show you pictures of that. So the first thing that you need is a drawing board. You need a T-square. You need set squares, 45-degree set square and a 30-degree, 60-degree set square. You need an instrument box. That instrument box should consist of a large size compass with interchangeable pencil and pen legs. You should have a lengthening bar. This lengthening bar is used to increase the radius size of your compass. You should have a small bow compass. You should be having a large size divider, a small bow divider. You should be having a inking pen and engineering scale set, right? You should be having some scales. Okay. You need protractor. You need French curve. French curves are used to draw continuous lines. Draw continuous lines through some given point. Say you have a point here, 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 and you have a point here. So to obtain a smooth curve like this of some irregular shape, we need some French curves. Okay. Apart from that, you need drawing sheet. You require drawing pencils, sandpaper block to clean the board that you have. You need eraser. You need drawing pins, clips, or adhesive tapes. You need a dusting brush. You need a drafting machine or a drafter. Right? You can have anyone. You can have a drafter, or you can have a T-square. Anyone will do. Right? You can have a roll on draw. You need stencils and you need sharpener. Now coming to drawing board. So a drawing board is rectangular in shape and is made of strips of well-seasoned softwood, and it is about 25 mm thick. It is cleated at the back by two battens to prevent warping. And one of the edges of the board is used as working edge, right? Say if this is your board, here you have an extension on which your T-scale or the T-square can glide smoothly on this, and this is basically called the working edge. So here, presentation of well-seasoned softwood. So these are your strips of well-seasoned softwood. And these are battens, right? So these they prevent the board from warping. Now this side is your working edge. This side is your working edge, and this working edge is made of paper. And on this, is very easy, and you can easily draw parallel lines using your. There are different sizes of boards that have. You have the B0 size, and dimension that you have for T0, for T1, for T2, and for parts, the stock and the leg. This looks something like this. So by gliding this T square, this is the working edge of the board. By gliding T square along, you can draw long parallel lines. Of screws or pins. The stock slide on it as required. Is used as the reference. Now the nearer edge of the word used. Okay. Okay, so this is your stock and this is your you should be using the bevel edge. Is the bevel edge. Is used for the working edge of the T square is also used for square to have a 45-degree place the T set square here, you have ultimately on the drawing sheet you can have lines. Right. So the T square also acts as a base using which you can draw vertical right? If you have the T square like this, place the set square like this, so then you draw a vertical line here. Right? Now if vertical different vertical lines can be the questions up to this? This at this point, right? So you say here you had drawn a straight line using your T square. Say again using your T square you draw a straight line here. So won't you get to parallel lines, to straight long parallel lines? Got it?
Yes, sir.
Right. And using combination of T square and set square, you can draw different types of lines, perpendicular lines, inclined parallel lines, etc., etc. You can easily draw that. Okay.
So, so which is the size of the board we require?
I'll come to that. When I'll be explaining the drawing sheet to you, I will come to that.
Okay, sir.
Okay. You don't have to buy anything. You don't have to buy a drawing board. Okay. Because the size of the drawing board that we have in our lab or the size of the paper that we use in our lab, you won't be using that. Okay. What you have to buy, I will be telling you after the lecture.
Okay, sir.
And I think you won't have to buy also. I think you all have it at home already, right? I'll discuss that later. So here is your T square. This is the working edge, and this edge is beveled. This edge is beveled. This is the blade, and this is the stock. Now this stock, it glides along the working edge of drawing board. It glides along the working edge of drawing board. Okay, so it might look something like this. Coming to set squares, you can have two forms of set squares. You can have a set square which is triangular in shape with one of the angle as right angle. So this is your 45-degree set square. Now the 30-degree, 60-degree set square of 250 mm length and 45-degree set square of 200 mm length, they are convenient sizes for use in schools and colleges. Now set squares are used for drawing all straight lines except horizontal lines, which are usually drawn with the T square. So all horizontal, straight and parallel lines, they are drawn using a T square. And inclined straight parallel lines, they are drawn with the help of set squares. Set squares along with T square. Okay, with the help of T square as well as set square, you can draw the other different types of lines. So in combination with T square, lines at 30 degrees, 60 degree angle with vertical or horizontal lines can be drawn with 30 degrees, 60 degree set square and 45-degree angle with a 45-degree set square. Right? Now the two set squares used simultaneously along with the T square, you can use that to produce 15 degree, 75 degree, 105 degree, etc. So you can use the combination of set squares, both the set squares as well as the T square, to get all such angles, 15 degree, 75 degree, 105 degree, etc. Now parallel straight lines in any position not very far apart as well as lines perpendicular to any line from any given point can be drawn using a set square. So here you have the example of the set square. Now in some cases, in the 30 degree, 60 degree set square, you have such types of markings, right? Now these are French curves. These are French curves and you use them to join different points and get a continuous curve. Now coming to the drawing instrument box. Now coming to the drawing instrument box. The drawing instrument box, it contains the following things. You can have a large size compass with interchangeable pencil and pen legs. You can have a lengthening bar. We can have a small bow compass. You can have a large size divider. You have a small bow divider, small bow ink pen, and you can have a inking pen. Let us just see that. So here is your instrument box. Okay. So this is basically a large size divider. Okay. This is your large size divider. This is your small size divider. Okay. And A combination of this and this is used to have a lengthening bar. Sorry, that is not your lengthening bar. This one is your lengthening bar, right? This one is your lengthening bar, and this one is attached here with the aid of other attachments to have a larger size compass. So this is basically your large size compass, but you can increase the size of the leg also using this attachment, which is called your lengthening bar. Apart from that, you can have small size compass also. Okay. Here, the compass is used for drawing circles, arcs. It consists of two legs hinged together at its upper end. Okay. A pointed needle is fitted at the lower end of one leg. So this is your pointed leg, while a pencil lead is inserted at the other end. So here, this is your pencil lead. Circles up to 120 mm diameter can be drawn with the legs of the compass kept straight. And while fitting this pencil or the lead that you have, there should be 1 mm gap between this pin that you have and the lead that you have, right? When the legs are kept absolutely straight and parallel to each other. This one is your lengthening bar. See here, if you attach the lengthening bar, circles of more than 150 mm radius are drawn with the aid of the lengthening bar. Right? So here, this one is your lengthening bar that I showed you in the instrument box. Now you have a small bow compass. It is used for drawing circles and arcs of less than 25 mm radius, and particularly when a large number of small circles of same diameter are to be drawn. Small bow compass is used. Then you need a large size divider. It has two legs hinged at the upper end. Here you have the hinge, and is provided with steel pins at both ends. So here one pin, this one is another pin, but it does not have the knee joints like you have seen for a compass. So dividers are used to divide curved or straight lines into desired number of equal parts, to transfer dimensions from one part of drawing to another part, to set off given distances from scale to the drawing. Right? So when you will be doing some drawing, right, while you will be practicing on your drawing sheet, you will be able to clearly understand what is the function of what. This one is your small bore divider. The small bore divider is adjusted by a nut and is very convenient for marking minute divisions and large number of short equal distances. Right? So here you have this nut. By rotating this one, you can increase or decrease the width of the legs. You have an inking pen. It is used for drawing straight lines and non-circular arcs in ink. It consists of a pair of steel nibs fitted to a holder made of metal or ivory. Next, you have scales, right? So scales are made of wood, steel, or plastic also. It can be flat or triangular cross section. 15 centimeter long and 2 centimeter wide, or 30 centimeter long and 3 centimeter wide flat scales. You get them commonly in the market. Now they are usually about 1 mm thick. This one is 1 mm. And scales are of greater thickness, have their longer edges beveled. So the longer edges are beveled if they have greater thickness. This helps in marking measurements from the scale to drawing accurately. So this is the beveled edge. Bevel edge. Both the longer edges of the scales are marked with divisions of centimeter, and they are subdivided in millimeters. So you will be requiring a scale also. This is your protector. It is semicircular in shape, and you all know very well that you use a protector to mark angles. Okay, flat and circular or semicircular. Most common type is semicircular, about 100 mm dia, and it has 1 degree deviations. It is used to draw or measure angles as cannot be drawn with set squares, right? All the different types of angles that you cannot draw using a set square, you use a protector for that. Here is your French curve. Again, the use of French curve when we will be drawing projection of circles and all these things, you will be able to understand the use of French curves. So French curves are used for drawing curves which cannot be drawn with a compass, and a freehand curve is first drawn through the known points, and longest possible curves exactly coinciding with freehand curve are then found out from French curve. So say you have a point here, you have a point here, you have a point here, like this. So it is not a perfect circle. So how do you get a continuous curve through this one? By fitting in the edges of the set square. By rotating and fitting in the edges of the set square, you can get a continuous curve like this. Then you have drawing pencils. So in your pencil, you will be mostly, you have used HB pencils, I suppose. So HB letter, it denotes medium grade. The grade of a pencil lead is usually shown by figures, HB, H pencil, or something like that. You can have H pencil or you can have B pencil separately. Now the increase in hardness is shown by value of figure put in letter H. So 2H, 3H, 4H. So as you increase this number, the hardness of the pencil increases. Similarly, the grade becomes softer according to the figure placed in front of letter B. So 28, 38, 48, 28B, 38B, 48, etc. So as you increase this number, the softness increases, right? So one is harder pencil, another is softer pencil. So the beginning of a drawing should be made with H or 2H pencil, using it very lightly. So the lines should be faint. The initial drawing should be faint and should be started with a H or 2H pencil, so that if you rub the lines or if you erase something, then there won't be deep markings. Okay, so unnecessary or extra lines can be easily erased later on. The final fair work, it is done with harder pencils, say 3H and upwards. The lines of uniform thickness and darkness can be more easily drawn with hard grade pencil. So H and HB pencils are more suitable for lettering and dimensioning, and for freehand sketching, where considerable erasing is required to be done, soft grade pencils such as HB should be used. Later on, I'll be telling you which one you have to buy. Here you have. See here. This is your HB pencil, H, 2H, 3H, 4H, 5H, 6H, okay? And here the softness increases. Now, as the softness increases, more amount of material is transferred to the paper and it appears darker, right? So using the soft grade pencils, you can have more darker lines, as you increase the grade of the hardness, you can get more faint lines. More faint lines, right? You can get that. So here are some classic examples. The lead may be sharpened to two different forms, conical point and chisel edge. Conical point is used to sketch work and for lettering, and with the chisel edge, long thin lines or uniform thickness can be easily drawn, and it is suitable for drawing work, right? So hard, these are the hard grade, these are the medium grade, and this is your soft grade. So soft leads are used for various kinds of artwork. These leads are too soft to be used in mechanical drafting. So these pencils you won't be using, and the pencil sketching that you do in artistic drawings, they are mostly done using 2B, 3B, 4B, 5B. The shading part that you do in artistic drawing, that is done using soft pencils, and the hard pencil, it is used in engineering drawing. Either the hard grade pencil or HB pencil, it is used in engineering drawing. Next, you need a eraser. I don't think you need an explanation for this one. Now, these are the things that you require for attaching the drawing sheet to the board. This is, you can have a pin, or you can have clips, or you can have adhesive tapes. So this is how it looks like if you go to the market. You can have a drafting tape using which you can fix the drawing sheet to the drawing board. You can have such types of clips, or you can have board pins like this using which you can fix your drawing. Now this is your sandpaper block. Okay. You need a duster to clean the sheets, preferably before the start of the drawing. Then you need a drafting machine. Now, I have explained to you about T-square. I have explained you use of set squares, right? Now, the advantage of T-square and set squares can be obtained on a drafting machine. You can combine all these three things into a drafter, right? So you can draw straight parallel lines using a drafter. You can draw any angles using the drafter. You can draw parallel lines at angles using a drafter, etc., etc. Right? So the combination of set square and T square, you can get it in a drafter. Most of the students at BIT, they generally use a drafter. This is how the drafter looks like. And here at this point, this is graduated with degree scale, right? So you can incline it, you can incline this one at different angles, right? So here you can easily combine the set square as well as the T square in the drafting machine. So at the upper hand corner, the drafting machine is fixed, and this is moved along the drawing sheet to draw different kinds of lines. This is a mini drafter. This is generally used by students. Okay, generally used by engineering students of first year. This one, mini drafter. See here, you have a graduated scale here, you have a graduated scale here, you have degree markings here. So you can set it at different angles and at different orientations. So here you have the drawing board with a drafter fixed to it. Like this, it looks something like this. Next is your roll and draw scale. Again, you can use it to draw straight lines, and they are in centimeter and they are subdivided in millimeters. So this is a 15 centimeter scale, or you can have a 30 centimeter scale. Now coming to drawing sheet size. Just a moment. So here is your drawing sheet that you have. The largest size drawing sheet that is used is the A0 size. Next is your A1 size, A2 size, A3 and A4 size. Now, how we get all these sizes? Let us just check this out. So this is your A0 size drawing sheet. This is A0, C841 1189. Now, if you divide it into two equal halves like this, then this half will represent your A1 sheet. Okay. Now, A1 sheet is 594 by 841. See here, this length, this is being half. So this will be 594. This is your A1 sheet. Now, again, along the length, if you subdivide this A1 sheet into two equal halves, then this is your A2 sheet. Okay. Again, this larger end, half of this one. So 420 by 594. Okay. Now
Hello
again,
guys,
this
welcome
longer
back to
edge, if
Android
you
Tips.
subdivide
Today
it
I'm going to
into
show
two
you some
parts,
of the main
that will give
highlighted
you a
features of Android
A2
10,
sheet.
which are live
Okay.
caption, smart
So
replay,
half of
sound.
594 is 297 by 420. Now this 420, if you half it again, then you will get a A3 sheet. Again, this A3 sheet, half of this longer edge is 420. So this is 210. This is your A4 sheet. Right? Now again, along the A4 sheet, you know it very well. You use it for in your Xerox machines, or you use it to submit assignments, and you get it commonly in the market. So this is your A4 sheet, and along the length, if you halve it again, you are going to get a A5 sheet. Now, depending upon the drawing sheet size, you correspondingly you have to choose the size of the drawing board that I have given you earlier. Okay, so I hope this clears your question now. Someone was asking which drawing board should we use. So depending upon the size of the drawing sheet you are using, you should be having the drawing board. Okay, say for A0 sheet, you should be having a B0 drawing board like that. So coming to the layout of the drawing sheet, this is again important for you because you have to prepare the drawing sheet in this manner. Okay. Just a minute, let me check out. Okay, now I'll just explain to you what you have to buy for yourselves. First thing that you require is a geometry box. The simple geometry box that you use for class 9, class 10 or in 11, 12 that you have used, right? You should be having your geometry box with you because there is no point in buying the instrument set that I have shown you because you do not have the drawing sheet set up or the drawing board set up. Okay, so you should be having a geometry box. Okay, you should be having scales, you should be having HB pencil, and you should be having a 2H pencil. Okay, any questions? So this is what you should be having. I hope you already have the geometry box. Am I audible?
Yes, sir, it was clear.
Yes, you should be having the geometry box. You should be having a HB pencil. You should be having a 2H pencil. You should be having eraser. You should be having sharpener, and buy A4 sheets. A4 size sheets. You have to buy that. Clear?
Yes, sir.
Yes.
Yes, sir.
Okay, sir.
Yes, sir.
Great. So this will be enough for your engineering graphics classes, for your online engineering graphics class, not your offline engineering class. Right. So here you should be having A4 sheet. In your A4 sheet, what you are going to do is draw a very thin border, say 10 mm, 1 centimeter border all around, and you prepare a title box here. In this title box, you have to write your name. You have to write your roll number. You have to write the name of drawing sheet. Say sheet 1, sheet 2, or say projection of points, projection of straight lines, all these things. So you should be having your name, you should be having your roll number, you should be having the name of the sheet, right? And before your name or anything, here you have to write Birla Institute of Technology, Meshra. Okay? Birla Institute of Technology, Meshra. You have to write that at the top. Right? After that, your name, your roll number, and the name of the drawing sheet. Okay? That should be present in your title block. Any other information that is required, you have to write it down here. What information you would require to write it down here? I will tell that to you. Okay? Now coming to the usage of different types of lines. Now you can have a continuous thick or continuous wide line. You can have continuous thin line. You can have continuous thin narrow line. You can have continuous thin zigzag lines. You can have dashed thick line. You can have dashed thin line.
Tutorial, you need a
The
Windows or
use
Linux
of all
PC
these
and a
different types
Nokia
of lines I will
7.2
be teaching
smartphone.
you one by one.
During the whole
when I'll be
procedure, the phone must be connected to the PC
going
with a
to
USB
projections
data
or any
cable.
drawing that
I
we
had
do,
some problems
right?
with the
For
USB
now, you should
connection.
be having
I
the
could solve it
information
by using a
and
USB 2
the
hub
application.
instead of
Please
a
go through
USB
that.
3
I
hub.
will be providing the PPT
If
to
you have
you.
similar
So you have
problems,
to
you
go
can
through the
also try
different
using another
applications.
PC. I am
For
showing
today's
a
class, you
tutorial
should know
from the
that these are
XDL
the different types of lines that you generally use. Here are some examples. Okay, the examples you can easily see here. Dimension lines for that, outlines, center line, cutting plane line, hidden line, etc., etc. So these are the different types of lines, and I will be explaining different types of lines to you through illustration of different types of drawings. So thick lines, visible line, hidden line, section line, when we require a hidden line, when we require a section line, when we require a center line, we are going to see that at a later stage. For now, you should be having the information that these are the types of lines that you have. Right? Now coming to dimensioning. Now, in engineering drawing, it is very, very important to provide, just a moment. सर बोलिए सर ग्राफिक्स का क्लास चल रहा है थोड़ा टाइम लगेगा ग्राफिक्स का क्लास चल रहा है सर टाइम लगेगा थोड़ा क्या चीज का टीम का हम्म हाँ वो तो ब्राउजर में खुलता है ना इसलिए पासवर्ड मांग रहा है उसमें तो आप लॉग्ड इन किए हुए नहीं है ना सर मुझे पता तो नहीं चलेगा लेकिन मैं उसको रीसेट कर सकता हूँ फिर आपको नया पासवर्ड देना पड़ेगा फॉरगेट पासवर्ड कीजिए ना देखिए मिल जाएगा हाँ हाँ फॉरगॉट पासवर्ड में जाके कीजिए ठीक है नहीं होता है तो उसके बाद मैं कर दूंगा रीसेट कर दूंगा पासवर्ड ठीक है Right. So Rahul Kumar, he has asked how many sheets we have to buy. See, since you are doing online classes, you will be requiring a lot of A4 sheets. Okay. So I would suggest you get a bundle of A4 sheets. Okay. Right. Right. So here you have the dimensioning style. So Bureau of Indian Standard, it defines dimension as a numerical value expressed in appropriate units of measurement and indicated graphically on technical drawing with lines, symbols, and notes. Okay. So basically, when you are providing any engineering drawing, you need to provide some information about the shape and size also. For that, you need some elements which is provided by dimensioning or the elements of dimension. So the important aspect of dimensioning are units of measurement. The most convenient unit for length is millimeter. So all dimensions that will be given to you, see here, it is just given 50, 40 like this, right? It is not given 50 centimeter or 50 millimeter. So when nothing is given to you, it is obvious that it will be in millimeter. And whatever drawings that you do on the A4 sheet, all units should be in millimeter, and at the top of the title box you should be writing all dimension in millimeter. Okay, all dimensions are in millimeter, right? So dimensioning is often done by a set of elements which includes your extension line, your dimension line, your leader line, your arrowhead, and the dimension, right? So whenever you are providing dimension, you should be having some extension lines like this. Now in between these extension lines, this is your dimension line and this is your arrowhead that you provide. And what the dimension is, actually you provide it by using the dimension text. Okay, so this is again your extension line and the arrowhead. Now there is a particular rule to draw the arrowhead. So when you are drawing the arrowhead in a dimension line like this, so a particular ratio is followed. So if this is 1, so this will be 3, right? So 1:3 ratio is followed for the width and the length of the arrowhead, right? Say like this, like this. So this is 3 and this is 1. Okay, so 1 and 3, correct? Any questions up to this?
Sir,
Yes.
सर थोड़ा आप बोल रहे थे ना मिलीमीटर सेंटीमीटर.
I did not get you.
The second line of this PPT, unit of measurement, the most.
You are saying
The,
about
the
yes,
important the important aspect of dimensioning.
all dimensions will be in millimeters.
Okay, sir. Okay, sir. Okay, sir.
Yes, yes. Right. So let us just check out the different attributes of the dimension line now. Right. So dimension line is a thin continuous line. It is terminated by arrowheads touching the outline, extension line, or center line. So I'll be just providing you this PPT. You just go through these points, and when I will be drawing something, okay, I will be explaining it to you in detail what I am doing. Okay. So there are different types of arrowheads that you have: open type, closed type, closed fill type, etc. Right? So basically you are going to use the either this one, you can use either this one, or you can use this one, closed and filled. I would suggest you to use both of them, right? So the arrowhead, how you should provide that is also given to you. So if this is x, this is 3 times x, this length. So if this is x, then this length is 3 times x. Okay. Now the extension line. An extension line is also a thin continuous line drawn in extension of an outline. It extends by about 3 mm beyond the dimension line. Okay. So here if you have say a rectangle like this should be 3 mm. The extension line, it should not touch the object, right? And it say this is around 1 to 3 mm, and this extension beyond the dimension line also it should extend by around 3 mm. So this should be preferably 1 mm where the extension line starts. Okay. Next is your arrowheads. So an arrowhead is placed at each end of a dimension line. So this is your arrowhead. Okay. Its pointed end touches an outline, an extension line or center line. The size of an arrowhead should be proportional to the thickness of the outline, and length of arrowhead should be 3 times its maximum width. Now next is a leader line. A leader or a pointer is a thin continuous line connecting a node or dimension figure with feature which it applies, right? So this is basically a leader line, right? So here preferably all the dimensioning text or dimension information that should be provided outside the drawing, not inside the drawing, right? So here if I wish to show that this is a circle of diameter 200, so I draw this dimension line, I provide the arrowhead, I extend this, and I increase the length like this, and I write phi 200, right? More details we are going to see later on. Phi 200. Phi is the symbol for diameter. Phi is the symbol for diameter. So phi 200 shows that this is a circle of dia 200 mm, and this is basically called a leader line. So here is an example. Just have a look at this. Phi 20, phi 15. So this is a leader line. Okay. Now this is 6 mm, 10 mm. You do not need to provide these things. It is not required. So all dimensions are in millimeter. Right? This is how you provide length. So dimension line should be drawn at least 10 mm away from the outlines, and smaller dimensions should be placed nearer the view and larger further away, so that extension lines do not cross the dimension lines.
Sir, we have to remember all these.
You have to remember all these things. While doing the drawings, okay, that will automatically, that will be injected in your minds, and you will remember it automatically, right? Now arrowheads should be ordinarily drawn within the limits of the dimension figure, but when the space is too narrow, they may be placed outside, right? So here at this point, if you draw the arrowhead like this, right, then it will be difficult to place the dimension text in between. In that case, you can place the arrowhead outside and you can place the text here. Now here again, if it is very difficult to place the dimension text also inside, you can place it outside like this. If it is difficult to place the dimension text here or here, then you can just use a leader line and you can provide the dimension. Correct? So this is how you can do. Same for angular dimension. Say 25 degree, you have easily placed it here. But if there is no place for this 20 degree, you place it outside. Again 7 degree, that is much more smaller. Then this will be 70 degree. Okay, you place it outside using a leader line.
Yes, ma'am.
Now this drawing that you can see here, 50 is placed here, the dimension lines they are crossing here. So this is wrong. It should be placed like this, 50 above and 25 like this. Okay. So dimension should be placed outside the views. Each dimension should be given only once. No dimension should be redundant. Now the dimensioning system that you have, they can be of two types. It can be aligned or it can be unidirectional system. I would suggest you to use the aligned system for your drawings, because for small drawings you use aligned system, and for large size drawings you have unidirectional system. Okay, in aligned system the dimensions are placed perpendicular to the dimension line so that they may be read from bottom or right hand side of the sheet. So this is your arrowhead. You can read it easily from the bottom. So you have to place it above the arrowhead like this above the arrowhead, or you should be able to read it from the right hand side of the drawing sheet. Okay, in unidirectional system what happens is you provide a break in between the dimension lines and you place the dimension text right here, like here that you can see. Okay, 40 like this. So the text is placed always vertically and it should be readable from the bottom. So dimensions are placed in such a way that they can be read from bottom edge of the drawing sheet, and dimension lines are broken near the middle for inserting the dimension text. Okay, so this is the difference between your aligned system and unidirectional system. Now the two systems must not be mixed in a drawing. Okay, the two systems must not be mixed. If you are drawing on a single sheet, if you are drawing using you are providing dimension using the aligned system, all dimensions should be provided in the aligned system. So you cannot mix up the aligned and the unidirectional system. If you are using the unidirectional method, you have to use the unidirectional method itself, right? If you have a look here, see the dimension text 5 here, it is placed like this in the aligned system so that it is readable from the right hand side. It is always placed above the dimension line, right? But here see that all the text, they are placed vertically. See here 60 degree how it is placed here and how it is placed here, right? So this is the basic difference between aligned system and the unidirectional system. And the two systems must not be mixed on a same drawing sheet. On a same drawing sheet. Okay. Now do not repeat the same dimension in different views. Say if you have like this, say front view and you have the side view, right? Now what is front view, what is side view, you are going to see at a later stage. But for now you should be knowing that same dimensions should not be repeated. Okay. The center line or axis line shall not be used as a dimension line with arrowhead at its end. Now center lines, they are used to denote center of circles. Okay, for any circle the center line is an absolute must. Okay, so the center line, it should not be used as a dimension line. Now the overall dimension shall be placed outside the intermediate dimension. That is, smaller dimension shall be placed nearer to the view and larger dimension should be further away from the view, so that extension line do not cross the dimension line. Okay. So this is the appropriate method. The extension lines, it is desirable that they do not cross the dimension line. So this is basically incorrect. Okay, so this is incorrect and this is the correct method. So the incorrect method and the correct method is both given for your reference. Okay, so dimension should be placed outside the view. It should be marked from visible outlines and should be given from the outlines or a center line of a hole. Right? So with practice, with more and more drawing practice, all these things will go into your head. Right? The reasons why the drawing is incorrect and why this one is correct, you can go through that later on. See here, incorrect method, correct method, that is given to you. Why it is incorrect and which one is correct and the reason, that is also given to you. Okay. So these are some more examples that you have. So you can just go through this PPT and you can learn those different aspects. Any question up to this? Any question up to this? Just what is proper and what is improper, that is given. So you can just go through that. Okay. I will provide this PPT to you. Is it clear?
Yes, sir.
Yes,
sir.
Right. So just some correct method and some incorrect method and some conventions that you should be following. And you just go through this PPT, and whenever I will be drawing something, apart from the drawing, I will be also telling you the correct dimensioning method of each of the features. I think that will be more suitable for you. Isn't it? Is it okay?
Yes, sir. Yes, sir.
Yes, sir.
Great.
Yes, sir.
Okay, so
You just go through this theoretical portion that I will be providing you, and practically while drawing, I will teach that to you step by step. Right? Any questions up to this?
Sir, the dimension line should not be placed inside the figure.
Yes, it should not be placed inside the figure. Absolutely correct.
Sir, how
You have
many
to avoid
drawings
that.
we will?
Yes. So after this, you have projection of points, you have projection of straight lines, projection of lamina, projection of solid, section of solids. 5. Okay.
Sir.
After that, you will be having quiz and viva. And after each class, I will be giving you assignment. You have to complete that. Okay.
Sir,
Yes.
sir, can you provide the syllabus of engineering graphics? We don't have.
Whatever that will be, I told you what all will be there. Okay. And one day, 1 or 2 days, I'll be teaching you AutoCAD. Right. Mostly
Yes,
mostly this is what you have. You have projection. There you have points, projection of point, straight line, projection of lamina, projection of solids, section of solids. Okay. And you have AutoCAD along with that. Whatever
And sir,
that you are drawing in drawing sheet, I will be teaching you in AutoCAD. You can practice that.
And sir, do we need to follow some books also, reference books?
I'll give you a reference book. I will upload it for you. Okay.
Okay,
There is a
sir.
book by N.D. Bhatt. In a similar way, I had provided you a soft copy of engineering mechanics book. Similarly, I will provide you a engineering graphics book. You can get a lot of solved examples there. You can go through that. Okay, Rishabh?
Yes, sir.
Okay. Any more questions?
Sir, we have to
No,
buy
sir.
a bundle of A4 na?
Yes, you keep that because we don't know up to when you will be having your online thing, how much it will continue. So if you just keep a bundle, then it will be helpful for all your assignments. Your assignment, your end semester, everything. Okay.
Okay, sir.
Not only for this subject, for other subjects also. Mishra sir, any more instruction?
Sir. Hello, sir.
Yes.
Hello.
Sir, PPT will
Just
be
a
enough,
moment.
sir,
Let
for
sir
us.
speak. Let sir speak. Sir is saying something. Sir, any more instructions?
No, the dimensioning part is over, na?
Yes, sir. Dimensioning, I have told them the basic part, and the remaining part I will be doing some drawing in PPT, and with each PPT, each of those drawings, I will be trying to correlate what is given in the presentation that I have supplied to them.
Acha. Okay. So next class we shall continue with next class we shall continue with projection of points
Yes, sir.
or dimensioning.
Sir, dimensioning, what is correct method, what is incorrect method, that I was telling them, and more examples are given to them in the PPT. They will go through that, and while doing projection of points or straight lines, generally I draw the thing, and along with that I will be telling them, see how to correlate whatever they have learnt in dimensioning with the actual drawing.
Okay.
Whatever feature they get while drawing different projection, how to provide the dimension, that we are going to correlate.
Okay, okay.
Yes, sir. So anything else, students? Someone was saying something?
Sir, PPT will be enough for us, sir. PPT.
Yes, it will be enough for you. And the soft copy of the book that I give you, that will be good enough for you.
Well, AutoCAD or MATLAB?
AutoCAD, not MATLAB.
Okay, sir.
What is the use of MATLAB? Do you know, Manish?
No, sir.
You will
why,
require AutoCAD.
yes, sir. That is why
You can download the student's version and you can log into it using your BIT Mesra ID.
Okay, sir.
Okay, you can register using that. Download the student version from the website. Any more questions?
Sir, do we have to maintain a lab file also?
You will be submitting the assignments, no? You have to keep the original drawing sheets with you. You keep it in a file.
Okay, sir.
Maybe
Okay,
if it
sir,
is
we
required later,
have
if you have to, when you come back, if you submit the hard copies, then we need that, isn't it? Obviously, the soft copy will be there with me, but we might ask you to submit the hard copy also. So keep that with you, the hard copy. Don't throw it away.
Excuse me, sir.
Yes.
Sir, you told us to take a geometry box, right?
Yeah.
So is the normal one enough, or is there any specific one for engineering?
Just the normal geometry box is enough.
Okay, sir.
Just the normal geometry box is enough. I think you should be having it.
Yes, sir.
Or you have
used
given
it
it
in
to
school.
someone. I hope
No,
all
sir,
of you have the old geometry box with you.
Yes, sir.
Okay. I will not force you to buy anything which will be very difficult for you at this time to go out and procure.
Okay, sir.
Anything else? Any more doubts? Anything else? Any more questions, students?
No, sir. No, sir.
Okay, so
No, sir.
we can end this class today. We are
Yes, sir.
again going to meet in the next class on Monday.
Okay, sir.
Yes, sir. Okay, sir.
There will be teaching you projection. Along with projection, how to provide the accurate dimensioning for that. That will be teaching you. Okay.
Okay, sir. Thank you, sir. Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.
Dipti sir, we are ending the meeting now.
Thank you, sir.
Okay.
Thank you, sir.
Thank you,
Now,
sir.
next class we shall start with projection of points, isn't it?